So the material that we're going to look at here today has to do with angles and their relationship to where the vertex is located on a circle. Okay, so the first set of relationships here that we're going to look at is what happens when what's the relationship between the intercepted arc and the angle when the vertex of the angle is on the circle? Right, so one example of this is going to be this instance here where you have a tangent and a chord where they intersect. Right, and we'll see the relationship as we look through this. So if a tangent and a chord intersect at a point, on the circle, okay, then the measure of each angle formed is half the intercepted arc. Now, we've seen this before, right? So if we looked at this relationship right here, we had an angle and an intercepted arc, and we saw that the angle is equal to 1/2 the intercepted arc. So we saw this on the inscribed angles, okay, where the vertex is on the circle itself. Well, the same is going to be true if you're dealing with a tangent and a chord. So when you look at the tangent and a chord here, if we look at this angle right here and we compare it to this arc measure, M, this is still the relationship, A is equal to 1/2 M. Okay, and so it's no different. The better rule is just if the vertex is on the circle, and then the intercepted, or the angle is half the intercepted arc. Now this also includes, again, what you see here is the measure of each of the angles. So if we call this angle B here, so if we're looking at the measure of angle B, and we think of this intercepted arc here, that's in the interior of that angle. B is going to be, if we call that, let's say this intercepted arc here, we'll call it N. Then angle B is going to be 1/2 of N. So it's the same relationship. It's 1/2 the intercepted arc if the vertex lies on the circle. And so see if you can apply that rule to the two problems at right. Okay, so these are two straightforward applications of this. What you see right here, you have this angle. It intercepts an arc of 94 degrees, and so angle 1 is going to be half of that measure. So 1/2 of 94. Remember, you can enter your answer as a calculation. You can also enter it in its calculated form of 47. And so that would be your relationship. Now remember, what you see, or what we saw here with the inscribed angle is if we're finding the arc measure is going to be twice the measure of that intercepted arc, or the inscribed angle. So the same is going to hold here as well. So here, M is going to equal 2 times the measure of A, or in the case of N is going to equal 2 times the measure of angle B. So based on that, we see this next example. If we have the angle whose vertex lies on the circle is going to be 1/2 the measure of its intercepted arc. That means that arc A to B passing through C is going to be 2 times 166. And so that would give you your answer here of 332. But again, you can enter your answer as a calculation if you prefer. Right, so that's a vertex on the circle. The next relationship is what happens if the vertex is in the interior of the circle. Okay, so if you have a vertex that falls in the interior of a circle, If you think about the two intercepted arcs as being M and N, oops, let me go back to this. So these aren't necessarily going to intersect at the center. Okay, so if you have this angle A right here, and you have these two intercepted arcs, M and N, the relationship that's going to be true for this is the angle is going to equal 1/2 the sum of those intercepted arcs, M plus N. So basically, the angle measured here is the average of those two angles, or those two intercepted arcs. Okay, now, the other way that you can think of this is because these two angles are vertical angles here, that means that there's this other angle A over here as well. They share the same measure since they're vertical angles. You could think of it as the two angles added together are equal to the two intercepted arcs added together. Right? And so think about what that winds up being, right? 2A is equal to M plus N, and then if you divide both sides by 2, you get that same relationship. It's the average of those intercepted arcs. Right? And so the wording for this is if two chords intersect, okay, if they do intersect, they are going to intersect inside of a circle. Then the measure of each angle is 1/2 the sum of the intercepted arcs. Now, there's another instance where we see this, okay, and that is if the angles or if the chords intersect at the center. Well, if this was the case, right, if that was A, then that means that this measure here, M, would be the same thing, right? It's equal to A. Central angles are equal. And so again, kind of think about, what that would mean. That would mean that this measure of M is actually A as well. That means this vertical angle A, this would be A. And so is it true that A plus A, or the A measure, is equal to 1/2 the sum of those two A's, A plus A? Yeah. This confirms the same thing. So this same highlighted relationship gives you the measure that the central angle is equal to its intercepted arc. But you don't have to find the intercepted arc on the back side of it. For the central angle, it's just equal to M. And we already saw that. This is one that we've already talked about, but that fits this category of the vertex on the inside of a circle. It still holds true for that. All right, so see if you can answer these two questions here, finding the unknown value for x in each of them based on that property, that the angle is equal to 1/2 the sum of the intercepted arcs. So if I am looking at this, angle 1 in this diagram here has these two intercepted arcs. So it's the average of AB plus the measure of arc CD. And if I find angle 2, the measure of angle 2 is going to be the average of these other intercepted arcs here, AD plus BC. So finding my unknown right here, here's my angle. So x is equal to 1/2 the measure of these two intercepted arcs. And again, you find the arc that falls in the interior of the angle being measured. So that's 135 added to 113. Remember, you can enter your answer as a calculation. So we could just enter that exact value here, or that exact calculation. And then if you actually do the calculation itself, you would get 124. So either the calculation or the calculated value is an acceptable answer. In the problem below, instead of the angle being your unknown, it's one of the arcs. And if that's the case, you set it up the same way. And now, this form right here is where this scenario, the way of thinking of it, makes it easier to solve because you can do a quick mental calculation. So if you know that this plus this is equal to this plus this, what you could do is say, well, this is 34 plus 34, so that's 68. What do you add to 44 to get 68? And you can solve that probably easier, just a mental calculation. Well, if you add 24 to that, you would get your answer. And so by thinking of it in this form where it's just the sum of those vertical angles is equal to the sum of the intercepted arcs, it often leads right to that as a calculated value. If you're setting it up as an equation, you would say 34 is equal to 1/2 the sum of these, x and 44. And so what you would do, multiply both sides by 2 to get rid of the half, and then subtract 44. And so the calculation would be 2 times 34 minus 44. Notice that's the same thing that we did up there, but if you take 2 times 34 minus 44, that leaves your answer 24. All right, so that's the second relationship. There winds up being 4 different relationships here that we're going to look at. Okay? The point on the circle, the point inside the circle, the point at the center, which is the central angle, and that also fits the point on the inside of the circle. The last scenario is what happens if that vertex point falls outside of the circle. So that's our final instance. And what happens when you have this vertex now falling outside? And these are the 3 scenarios. You have a tangent and secant intersecting outside. You have 2 secants is the second example. And the last example, you have 2 tangents intersecting. In each of those cases, the relationship is there's 2 intercepted arcs being formed. So here's your vertex outside. If we look at the angle, is right here. We have this arc M and we have this arc N. So they have further arc and the closer arc. The angle measure is going to be 1/2 the difference between those. So if we take the further arc minus the closer arc and divide by 2 or multiply by 1/2, we'll get our measurement. And so looking at these in each of these cases here, if the angle's vertex falls outside the circle, it's going to equal 1/2 the difference of their intercepted arcs. So here again we have M and N. So 1/2 of M minus N. And here we have M and N. It's the same idea. Angle 3 is equal to 1/2 the difference of the furthest arc from the closest arc. And then finally, this last example, angle 2 is equal to this whole measure M. Now notice this closer measure of N is actually M and N together form a full circle. So you could either think of this as being the same thing, right? 1/2 the difference of their arc measures. But you also know that if we took M plus N in that situation, it's equal to 360. So N is actually 360 minus M. So if you kind of look at this, M minus 360 minus M, what you wind up seeing is that you have 1/2 of M minus 360 minus a minus, which is plus M, giving you 2M minus 360. And if you multiply or distribute that 1/2 through, you get 1M minus 180. Right? And so that would be sort of the alternate way to think of that. Angle 2 is equal to M minus 180. For the other ones, you have that relationship that the angle is 1/2 the difference of those intercepted arcs. Right, so see if you can try these 2 instances first. Again, this is 2 secants. This is a secant and a tangent. Okay, see if you can find the missing values for those, please. So this first example here, your angle of 28 degrees is equal to 1/2 the difference of 77 minus the closer arc x, and then you solve the resulting equation. So if we multiply both sides by 2, here we get 56 is equal to 77 minus x. Subtract 77 from both sides. That gives us a negative 21 is equal to negative x. Change the signs, and we get our x value to be 21 degrees. Again, it is an arc measure, so it's measured in degrees. And the second example here, secant and tangent intersecting. The vertex lies outside the circle, so that angle measure is equal to 1/2 the difference of the intercepted arcs, which was 121 minus x. And then again, solve this using the same process. Double everything to get rid of your half. So that gives you 82 is equal to 121 minus x. Subtract 121 from both sides. You get negative x is equal to, and if we took 82 minus 121, negative 39, change the signs, and so you get your angle measure, or your arc measure x, to be 39 degrees for that. Okay, so this is the vertex outside the circle. Okay, the last slide here is just kind of building from that last part, the one that we haven't done, which is the 2 tangent segments. If 2 tangents intersect, okay, we saw again that the arc measure, or the angle measure, here's A, here's M, and here's N. A is equal to, now you could do the full calculation, right? You could say 1/2 of M minus N, but because of the relationship that we just saw, or that we looked at in the other example, we saw here that it's equal to just the difference between the given arc measure, the furthest arc measure M, minus 180. And so if we take that, the equivalent is M minus 180. And so either of these forms is going to be acceptable. All right, so see if you can answer these 2 questions here, given the furthest arc and the near arc. Can you find that relationship? Okay, so when you're finding this, the first thing you need to do is if you have 2 tangents intersecting, if you don't have the further arc measure, you just need to solve that. So this is going to be 360 minus 110. Once you complete that, you wind up 250. And so your angle, or your measure, is just going to be 250 minus 180. And that is your solution, which is 70 degrees. Again, you can put your answer as a calculation if you want. Okay, which means on this one, same thing, right? Here, you're given the actual arc measure on the outside. So if you take that arc measure, 240, and subtract 180 from it, you get your answer. And again, if you simplified that, you would get 60 degrees for that. All right, there's one final type of question that I do want to go through, and we're going to go through the 2 scenarios of it. Okay, so what if you have this same relationship here? So again, those tangents intersect the radius at 90 degrees. What if I told you this angle and I asked you to find either one of these? So let's say we wanted to find this outer arc here. Okay, I want you to see if you can find that, please. If we use the same formula, right, the same relationship that A is equal to M minus 180, we're still using that relationship. We know what A is. A is 39. is equal to m's are unknown minus 180. And so all we need to do to find m here is to add 180 to both sides. So our arc measure here is going to be 180 added to 39, meaning 219 is this whole arc measure. What if we were given, so I just copied that, and let's say instead of the, let's say we were given this angle measure again, we'll call it 18 degrees here. And what if we're trying to find this closer arc measure? We'll call it n. And see if you can find n in this instance, please. So one, you could just find what m is, right? So one way to solve this is we could just calculate our m value. So we could say that 18 is equal to m minus 180. Add 180 to that. So we get 198 is equal to m. And then n is going to equal the rest of that circle, right? 360 minus that given measure. And so if we took 360 minus 198, we're left with 162. And so there would be our answer. Okay, so that's one possibility. Okay, let's build from this. Okay? So I'm showing you that possibility because it doesn't require you to memorize or remember anything other than what's already up here. But if we took this relationship right here, A is equal to, if we wanted to find n, well, what we know is that this m, that the m value here is 360 minus m, right? Or minus n, if we put this in terms of n. So if we replaced m with its equivalent, 360 minus n, and then subtracted 180, you would get your measure here, which is 360 minus 180, which is 180 minus n. And so what we could have also done here is we could have just said that 18 degrees is equal to 180 minus n. And if we solve for n for this, subtract 180 from both sides. So 18 minus 180 is the negative 162. Is equal to negative n, change the sign, and you get the same thing. So if you want to remember another form of it or a different formula for it in terms of that, you could also find an equation for the angle in terms of just the near arc measure. Okay? So both of those exist for you to use in your calculations.